Welcome to the afternoon sessions. I am the opening for Daniel Kahneman, as I've been told. So just to keep the suspense, I will talk about something that is expected to be very different from what he's going to talk about. I'll talk about mechanism design, and in particular, informed principal problems. So obviously, I'm standing on the shoulders of giants, including some of them in this room. But what I'm going to talk about mostly today is based on some work I've done with Frederic Koestler, who's at Paris School of Economics. So in the main mechanism design paradigm, only agents have private information. And the big distinction between the main paradigm and informed principal problems is that the designer has private information. Now you would tell me, why would I care about this? Well, in many problems where somebody is choosing a mechanism or a procedure, the person who is making that choice has private information. For a concrete example, think about a privatization agency, which is essentially a huge asset development fund. They have these assets, these companies, and they know things about them. They do some due diligence. And maybe they choose the selling procedure depending on the results of that due diligence. So they have private information when choosing the procedure. Or think about a firm who wants to purchase an insurance plan for its employees. It has private information about these employees. It knows how many sick days they had. It knows their distribution of age and so forth. Some of this information could be private. Or a government agency procuring a new missile or a new technology or a new patent for, or a new research grant for a development of a new product, drug product. They might have private information about how valuable this technology is. So these are some examples. So now you will tell me, okay, mechanism design is very, very general. So why can we not really put that problem into the general language? So in particular, we can think that among all of these agents who have private information, we can call somebody agent 0. And of course, the revelation principle still will apply. So we can characterize all feasible mechanisms who are giving incentives to everybody, including the designer, to tell the truth and participate voluntarily. So agent 0 would just be one among these agents. And as we all know, the revelation principle is a parsimonious way to describe anything feasible that could arise from any game. Now, why is that not enough? Obviously, as we know, there are many feasible mechanisms, and different types of agent 0 could disagree of which mechanism is good. And even when they all agree, finally, that's okay, now I am agent 0, I have kind of come to terms with myself, that's what I'm going to propose. Then you might, because this is a choice made at the interim stage, like a game, some type of agent 0 could say, okay, this is the plan we agreed, now I want to deviate. So let me give you a concrete example where different types of the principle disagree. So this is a very simple example in the sense that there are just two types of principle, S1 and S2, and they are both equally likely, and the agent is doing nothing here. There is no private information of the agent can just agree to accept the mechanism or not. So there are three decisions to be made. The status quo, which will give 0 to the principal and 0 to the agent. There is decision 1, which is we build a pool, which will give payoff of 9 to the principal if he is S1 and 5 if he is S2, and to the agent -2 if the principal is S1 and 3 if the principal is S2. And there's another decision, the library, that gives S1 5, S2 9, and to the agent 3 if the principal is S1 and -2 if the principal is S2. So now you are the agent. You don't know whether the principal you're facing is S1 or S2. And all you can do is accept or reject these mechanisms. So what is a mechanism? A mechanism here will just specify what we're going to do outside of these three options. And of course, it could be something random. But let me propose something very simple to you. Suppose there is a mechanism that says if the principal's type is S1, if the principal subspace is 2, we are going to just make a pool. So that is chosen with probability 1. If that happens, if that mechanism is implemented, type of principal 1, S1 is going to get 9 and S2 is going to get 5. Another mechanism is one where, regardless again of the principal's type, we do the library, and the payoff vector is 5 and 9. So now you see that if you're a type of principal 1, you prefer mechanism M1. If you're type principal 2, you prefer mechanism M2. So maybe another mechanism would be, let's try to make every type of the principal happy. This mechanism will prescribe probability 1 to build in a pool if the principal is S1, and probability 1 to build in a library if the principal is S2.
What do you mean by this M1? P full S1 plus P full S2 equals 1, but if I'm S1, what is the meaning of P full S2?
Oh, the mechanism that's a very good question. The mechanism is like a computer. So it will specify what we're going to do regardless for each realization of my type.
So at what point in time do we decide on this mechanism? From without the type?
At the interim stage, I'm going to tell you in a minute. So that's we're going to decide, we're going to propose a mechanism at the interim stage. So I will propose a mechanism knowing that I'm S1 or S2. So suppose now that this mechanism is proposed. This mechanism, if it's accepted, which it will be accepted because now it's a contract. This is the mechanism specifies that if the principal actually has incentive to tell the truth that he is S1, and in this mechanism, he will have incentive to report the truth once we have the program, because regardless of what he says, we're making the pool. The payoff vector is going to be 9, 5.
So the principal is not the mechanism designer.
No, the designer, the principal is the designer, but once you design the institution is there. I am choosing the auction with the reserve price. If the reserve price is there, I'm not changing it afterwards. The reserve price could depend on my type, and it could be a function of my type, and I'm choosing this whole function. So this will become clear in the talk. I want to illustrate a very simple point here, that different types of principal like different mechanisms. S1 likes M1, S2 likes M2, and there is another mechanism, M3, which basically prescribes the pool if the principal is S1 and the library if the principal is S2, and that would give a payoff vector of 9, 9. But that mechanism is not feasible, because if we're ending here when the principal's type is S1 and here when the principal type is S2, somebody's not happy. The agent is getting -2. The agent doesn't want that. So this mechanism M3 is not feasible for the prior. Yes?
I got a bit confused from your earlier, what you said before this slide, is that the principal can't commit to the mechanism, and the principal can deviate from the mechanism.
It's going to be a game. Yes, of course. We are going to talk about equilibrium mechanisms here.
Then M1 and M2, the principal can deviate from them, right?
I didn't say that they're equilibria. Here, I didn't use the word equilibrium. I'm not going to talk about equilibria of this example at all. I'm just using this example to just show you something that maybe is very obvious, but I want to make it very concrete to you, that different type of principal like different mechanisms. I haven't used the word equilibrium here. I haven't even told you what the solution concept is going to be. So, yes, sorry.
But just to clarify,
I'm sorry, yes.
once the principal is proposed a mechanism, then deviation is no longer possible. Deviation means deviating from what you thought the principal was going to do. Once M1 has been proposed, that's
Absolutely,
it.
yes.
The agent can accept or reject it, and if the agent accepts that, that's the end of the game.
Yes, thank you. Okay, so here the key distinction between informed principal and standard mechanism design is we are going to be thinking about, there's going to be the set of feasible mechanisms and then equilibrium mechanisms. And we're going to be thinking of a game where the principal proposes mechanisms, and as Erica clarified, once a mechanism is accepted, we are playing the mechanism. And there is an issue that mechanism proposals may signal information about the principal, and this potential signaling of information could make some mechanism that would be acceptable if the belief was the prior be non-acceptable anymore. So, for example, if mechanism 1 is proposed by both principal types, then the posterior when I see M1 is the prior, and as we saw, the agent will accept that mechanism, and the payoff vector that will result to the principal is going to be 9, 5, and minus 2, 3. However, suppose now that the principal strategy is that S1 proposes M1 and S2 proposes M2, then obviously the agent, when he sees M1, he says, I'm dealing with S1. I'm not going to accept this because I'm going to get minus 2. And the same thing with M2. So if we have different principal types propose different mechanisms, the agent's beliefs may change. We'll see that this is going to not to be a big issue, but I will explain why. What is going to be more important in trying to find what mechanisms are actually proposed in the equilibrium of this game, where the mechanisms are proposed at the interim stages? How can we identify mechanism proposals that are robust to arbitrary deviations? So now, when we want to establish that some mechanism is an equilibrium, we have to show that no matter to whatever mechanism the principal will deviate to, no matter what, and unfortunately we will not be able to restrict attention to direct mechanisms of path. We will have to think about general mechanisms. Whatever thing I deviate to, I have to be able to find some belief of the agent about the principal, and an equilibrium play of that mechanism given that belief that results to an outcome, and the relevant part of the outcome is going to be the vector of payoff for each principal type, such that no principal type would like to do that. And that's the tricky thing. So in some sense, we've seen amazing lectures here on information design. Here we're going to be doing some belief design of path. We have to find a nice way to write. If we want to show that something is in equilibrium, I have to find a nice way to assign beliefs to mechanisms, and the right beliefs are going to be mechanism dependent. In some cases, when we've solved signaling games, sometimes it's easy to pin down what is the right belief to kill deviations, because in many models of that there is a bad type. So let's say there is the inefficient worker, or there is the low quality seller. So if I see a deviation, if I see a price 10, I'm thinking it's the low quality seller who is deviating, and this price is not a deviation. Here what's going to be different is that there is no right belief that works for all mechanisms in general. All right, so I'm coming to the specifics in such a second. So there are going to be three things that are going to be useful here. We will have to worry about incentives for the seller or the principal. I'm going to be talking about sellers in particular here, but that's straightforward. By the revelation principle, we're going to have to deal with the issue that mechanism proposal signal information. But that again, that's not a very big issue due to the inscrutability principle, which I'm going to explain in a second. The hardest issue is going to be to find mechanisms that are robust to deviations to any mechanism.
What's the difference between principal being principal and just another agent in the standard mechanism? Right?
He can choose the mechanism.
But isn't there a reduction? You choose the row.
Different types of principal can prefer different mechanisms, and the choice is at the interim stage.
Okay.
That's what I was trying to illustrate with the example with the pool and the library. And that's what in the first slide I put it intentionally towards your thinking, because mechanism design paradigm is very different, is very general. Why can I not express this problem in that language? So for these two lectures, I'm gonna base these two lectures primarily on informed seller problems. So we've seen a lot of yes.
I just want a quick question about what you said about indirect mechanisms. Is the reason why you have to look at indirect mechanisms because you care about which equilibrium the agents would play off path? And it may be that there's by choosing an indirect mechanism, the designer can restrict the class of equilibria or narrow down certain equilibrium behaviors.
The reason is that off-path beliefs are arbitrary, and when you have, you can actually have many more payoff vectors achievable by indirect mechanisms than with just direct. So I'm going to give an example in the next lecture. Is that okay if I postpone this question? It's on the slides, but I don't want to, it's not like a very simple, I don't have maybe Eric has a simpler explanation. It's not as, you can get more payoff vectors off equilibrium path with more messages than types. And that's so it's easier to kill deviations with direct mechanisms only. So now I'm thinking, like a better answer to your question is the following. If I had a mechanism that is immune to direct deviation only, I'm not sure that it's immune to indirect deviations. And so it's a bigger set, because you get more payoff vectors, something to be in equilibrium, you have to be able to allow the principal to propose a game. So suppose you have only one type, and I'm going to tell you to play a game that has 10 actions. Maybe your behavior and what is going to happen when I give you this game is different than if I ask you your type, which I know what it is. So that's kind of the intuition. And it's going to be very precise in the next lecture, where I will have to give you, I will explain why I'm going to show you next lecture. So I want to go slowly. So today I'm going to analyze a problem that is rich in some dimension, but simple in one. So in both lectures, there's going to be one seller who has private information about product characteristics. I'm going to denote that information S. It lives in a finite space, big S, and for many results, this S could be even a multidimensional object. There is one agent who has private information. We can call the private information taste, and it lives in a finite set. And there is a prior about the seller's type. I call it mu naught, just to not change the notation with the persuasion models we've seen. And there's a prior about the buyer's valuation. About the buyer's type. The buyer's valuation depends both on S and T and is a real value function. And the seller's information, the seller's reservation value or cost depends again both on S and T, and it's a real value function. So these functions are going to be very general. I'm not going to impose any assumptions on monotonicity nor single crossing. So this function captures many different problems in I/O. So S could be a completely vertical dimension, or it could be a horizontal dimension. So this model encodes Hotelling's model and Akerlof's model as a special case. And I'm not going to make any assumption on the reservation value. There's going to be one important simplification that is coming. So far, everything is general. So what's going to be the difference between this lecture and next time's lecture tomorrow? In today's lecture, we are going to be in the main paradigm of mechanism design, and we're going to model private information as being soft information. So any type can mimic each other. Tomorrow, we are going to give the seller evidence structure. So I'm very happy that we had Eddie and El-Halan give here lectures on mechanism design with evidence. So next lecture is going to be an informed seller who has evidence. And as you were probably realizing when I was mentioning the examples, in many real-world cases, when a seller has information, it could be in some sense certifiable. So the privatization agency could show you some accounting documents, or if I'm selling wine, I can give you a free sample. So, but in today's world, the information is soft, as in most mechanism design work. So, in this allocation problem, an outcome of the game is simply whether trade takes place and at what price. So it's an allocation. An allocation maps types. This is not a mechanism, this is an allocation. Maps types. So maps will as an outcome of this game, which I'm going to describe in a second, will specify for each vector of types S and T, what is the probability that the good is going to go from the seller to the buyer, and a transfer, an expected transfer. So P is the probability of trade and X is the transfer. And now for each possible vector of types, the seller's profit is X, the amount of transfer he gets, minus the probability with which he sells the good times his reservation value or cost. And the buyer's utility is the probability he gets the good times the utility minus X. So you see here, everything is linear in the outcome, P and X, which is a special case. And in a minute, I'm going to talk about the literature, and I'm going to specify how this is different from the literature. And what is going to be very important for us in terms of notation is going to be this V of S. This is the seller's profit as a function of S. So why this is important? Because when we are thinking about mechanisms and how they are played, each mechanism together with a play is going to result to a vector of profits, one for each seller type. So we're going to have this vector of profit arising, and then we want to identify which vector of profits are immune to deviations. So these are going to be our important objects. And here I'm writing also the buyer's, interim payoff, which is the expectation of U with respect to S. And I'm using here an arbitrary belief mu because at some parts of the game the belief will change, especially after deviations, as we're going to see. So I would like to be able to describe what is feasible as a function of arbitrary beliefs of the buyer. So are there any questions about the environment? So this is a special environment. It assumes risk neutrality, and it assumes that the payoffs, both of the agent and the principal, are linear in the outcome. So this is the mechanism proposal game. So tomorrow I'm going to write a slightly different game because there's going to be evidence, but it's going to have a very similar structure to this. So first types are drawn, and the seller will propose a mechanism after he knows his type. So the types are drawn, and the seller will propose a mechanism. So what is a mechanism? A mechanism will specify some language for the seller, messages, some messages for the buyer, and a mapping that will map those messages to a probability of trade and a transfer. So the seller will send a message. The buyer, so then there is the strategy of the seller will be to specify basically a message or a probability distribution over messages as a function of his type. Well, we can allow for mixed strategies, obviously. And the strategy of the buyer will specify whether to participate or not, and probability distribution over reports as a function of his type. So obviously I have simplified this on the slide. So the play of this mechanism implements an allocation. So an allocation is implemented as a function of the mechanism M and the reporting and participation strategies of the seller and the buyer. So to repeat, we have this mechanism, which is this language, is messages, and a mapping from those messages to probabilities of trade and transfers. And each player will choose a reporting and participation strategy. So reporting strategy will specify for each one of my type a probability distribution over these messages for the buyer, and the same thing for the seller. So obviously, the proper definition of this, you can find it in, yes?
Sorry, what is this? When you hear first the seller sends a message, then buyer participates, then she sends her message?
No.
No?
The types are realized. Seller proposes a mechanism.
Okay.
Types realized 1. Seller proposes 2. Simultaneous choice of strategies and determination of what happens. There is no participation decision before. Everything is simultaneously. This is acceptance and reporting is simultaneous here. And this, so the sequentiality is only that the choice is done after you know your type. And after the mechanism is there, then we input stuff in the mechanism. We choose how we're going to input stuff, and then this determines an allocation. So as I said, the above sentence hides a lot. So if you want to read properly what this means, I will refer you to a paper by Marson in Econometrica, who spends 2 pages to explain this.
So
Yes.
The message of the buyer does not include whether he participates or not.
Excuse me?
Okay.
Yes, you can actually encode it in one of the messages, but you can decide it's simultaneous. So as I said, here we're going to have chip talk messages. Next time the seller will also have to certify information. So then we have to think about when is the canonical timing to certify, and that's going to be discussed next time. So here the literature is not really rich, but it has 3 beautiful papers that I really recommend reading. And each of these papers is admirable in very different ways. So all 3 of them I highly recommend. They're one of my favorite papers among others. But okay, so the first paper, so here we have a paper in Econometrica by Myerson in '83, who looks at very general environments. So here, the utility of the agent, let's think about the agent, can depend in arbitrary ways in the principal's type and on the agent's type and on the decision. So it doesn't have to be linear. The decision, so in particular here, our decision was a probability and a transfer. This is entering linearly. So he formulates the inscrutability principle, which I'm going to explain in a minute. And Myerson's kind of a worry is like, how can we reach a compromise? Different principal types like different mechanisms. What are reasonable ways to reach a consensus? So most of the paper, he formulates he writes the game, as I wrote it in the previous slide, that's from Myerson. He writes down a solution concept, which we're going to introduce, the expectational equilibrium, in a second. But he arrives to something that is an equilibrium through an indirect approach by formulating a cooperative solution concept. So he talks about core and unblocked mechanisms, safe mechanisms, a lot of interesting solution concepts that I don't have time to explain here, but I'm going to hint through the explanations. But the main result is that he axiomatizes what he calls neutral optimum. So essentially, allocations that reach a good compromise, and he establishes that those things exist and that there are equilibrium allocations. So Myerson establishes existence of equilibrium of an informed principal problem, which is not a trivial task because it's a complicated game, through the characterization of these cooperative solution concepts and showing that this neutral optimum is an expectational equilibrium. So that's what he's doing. Maskey and Tirole, in 1990, they look at a very general model of private values. So in Maskey and Tirole, the decision again enters in the agent's type in an arbitrary way. So not like in the allocation problems I'm going to look at here, in an arbitrary way. So not necessarily linear in transfers. There are transfers, but they're not entering linearly. And I hope I'm doing an appropriate representation. The important thing in Myerson is that, in Maskey and Tirole, is that we can rank types of the agent. So the special feature here is that S is not entering in the payoff of the agent. So the agent cares about the decision that the principal is going to choose, but does not care per se about the type of the principal. For example, think about a seller whose private information is his cost. I don't care about your cost. I care about whether I like your wine or not. So this is a private value model. The seller's information is about his cost, but per se as a consumer, your cost does not affect my willingness to pay. And they establish so in that very general model, they define they define and establish the existence of what they call strong and constrained Pareto optimal outcomes or allocations. So this is a term that maybe not many of you have heard before, or maybe some of you or everybody has heard before. But basically, in mechanism design, usually we have some objective function. Either we want for an optimal mechanism or an efficient mechanism. In this game, we don't know what's going to be an equilibrium. So one of the big insights of this paper is actually to figure out what thing actually is going to be an equilibrium. And these in the private value model, they actually show that Pareto optimal payoff vectors of principal, in a very strong sense, are equilibrium allocations, and they are generically unique. So so this paper uses a beautiful construction relying on techniques from general equilibrium theory to establish existence of SUPO, of this Pareto optimal payoff vector for every prior, and that's a very beautiful result. I'm going to talk about SUPO next time, because it turns out that although this solution concept was developed for a private value setup, it is useful for a general interdependent value setup, which we didn't expect at the beginning, but it turns out to be extremely useful. And what is the main takeaway for our environment, which is very special? So when you have linear in transfer payoffs, what is going to be the main takeaway from this paper is that the SUPO, this Pareto optimal payoff vector, turns out to coincide with the payoff vector you would get if the principal was maximizing, was choosing the best mechanism type by type. So think about Meyerson's optimal auction problem. In Meyerson's paper, the seller does not have private information. Suppose now that I give him private information and I have seller type S1 and seller type S2. So I let S1 choose his mechanism and I let S2 choose his mechanism. This is a mechanism that I can propose as a mapping from S1 and S2 to probabilities and outcomes. This is the full information optimum. And this coincides exactly with SUPO in the case of linear transfers. So basically, this paper by Maskey and Tirol, it has one agent, but I think that doesn't really matter. It shows that with private values, when you have a model like Meyerson's, you know that you already know the optimal auction for an informed principal with private values and linear transfers. Because basically, you just have each seller type choose optimally his mechanism, and that's going to be fine. So obviously, that's not obvious, because you might wonder, so why does S1 does not want to mimic S2? Yeah, exactly. This is exactly right. And because the buyer does not care about whether you are S1 or S2. Exactly. So in private values, the buyer does not care whether you are S1 or S2. So for that matter, S1 could do whatever S2 was doing and vice versa. So they don't have a conflict, but this conflict is not due to private values. The fact that they cannot benefit. I mean, they don't have a conflict, but they could benefit by cooperating a little bit, because now the buyers are at a disadvantage against the seller, because the buyers don't know if it's S1 or S2. So maybe the seller could have some way to leverage this uncertainty of the buyers to increase to increase how much money they're extracting from those buyers. Are you following me? So although we don't have a conflict, we could actually come together and do a bit better. And this result shows you we cannot when payoffs are linear transfers, but in general, yes, you can, although we are in private values. So all of this is not meant for you to understand. These beautiful papers is to whet your appetite to read them. And next lecture, I'm going to talk about more about this, because this is private values, and as I said today, I'm going to talk about interdependent values. A paper subsequent to Mask and Tirol, also by Ilankaya, looks at Myerson-Satterthwaite's problem. Buyer-seller, again, private values, and there is again this result that the full information allocation is an equilibrium and actually turns out to be an ex-ante optimal mechanism. So these words in blue here are important. We're going to be coming to them at several times in the talk. The SUPO is going to show up a lot next time. Full information is going to show up a lot today, and I'm going to explain it again. An ex-ante optimal mechanism is also going to show up again. I'm going to explain it to you in an example in just a second. So the ex-ante optimal mechanism is a mechanism the seller would choose before he knows his type. Before. That's the best he could do, because if I can commit before I know anything, they have no issues to think about deviations and all of these things. So it turns out that in this game, an equilibrium mechanism consists with the full information and ex-ante optimal. So what did I do to the clicker? There. Okay, so the private value paradigm has been generalized in two papers by Milovanov and Treger. So Milovanov and Treger drop some assumptions in Mask and Tirol, and in particular the assumption that we can anticipate which constraints of the agents are binding for each principal types. This is a bit technical. I'm not going to talk about it today, but I'm happy to elaborate more tomorrow or afterwards. And they look at private values again, and they actually show that in some cases the equilibria are ex-ante optimal. So these are private values, that's why I'm not spending a lot more time. So Mask and Tirol in 1992 look at a common value environment, and it's actually pure common values. I don't think that's essential, it's just to make their arguments cleaner. So the agent's type now just depends on S. So think about the principal being a hedge fund selling assets. So now how much buyers want to pay for these financial products just depends on the characteristics of the financial products. It's a common value environment. Oh, sorry, payoffs are not linear in transfer. This is wrong. So forget about this. Sorry, this is a typo. So they define a number of solution concepts, and the main result is that they define this as outcome that's called Rothschild-Stiglitz-Wilson allocation. So this object is defined by a number of maximization problems. So basically, it says that suppose we look at an allocation, a vector of payoffs for the principal, which is defined such that each component of this vector is maximizing the particular principal's type payoff, subject to a given bound, subject to no principal type getting less than the other components of the vector, and subject to exposed participation constraints for the agent. And the main theorem says that if that object is interim efficient for strictly positive beliefs, which means if it maximizes some weighted sum of the principal's type's payoff for interior beliefs of the agent, then anything feasible that gives all principal types above this payoff is an equilibrium. So there's a continuum of equilibrium allocations. So why can we not use the theorem of Mask and Tirol here? Because in the allocation environment we're looking at, the Rothschild-Stiglitz-Wilson allocations may not be interim efficient. So this theorem is not applicable. And then there are some other papers that kind of look at different extensions, but I won't talk about those. All right, so the first part of the first lecture will be based on some, as I said, some work what I've done with Frederick Koestler, where we're going to look at this special case, where the principal cares only about revenue. In the private value model, that's a very easy answer, just told you. So what we do, we characterize the entire set of equilibria for general valuation functions. So although we are restrictive in this dimension, we allow for a lot of richness in this dimension. And we show that there is a continuum of possible equilibrium outcomes. We show that ex-ante optimal mechanisms are always in this set. So a mechanism that the seller will choose before he knows anything is always an equilibrium. And that is a nice result, because at least you can get an equilibrium of that informed seller problem in a very easy way. You solve for the ex-ante optimal mechanism, and a particular one of those is an equilibrium. I will tell you, the one that is incentive compatible for the seller. And we also derive, we are going to show that the seller always benefits from having private information, in the sense that there is always an equilibrium which will give the seller weekly higher ex-ante profit compared to what he could have gotten if his information was available to the buyer. So if we had basically Meyerson type of auctions, or post prices in this case, because we only have a buyer. And we're also going to derive conditions under which actually the seller is indifferent between whether or not he's privately informed. Sergei Ismalkov and Balestieri, they have a paper that looks at a particular case of our model, which is a purely horizontal differentiation problem, symmetric. They characterize ex-ante optimal mechanisms and show that it's an equilibrium. So these papers were sort of contemporaneous. They have a different objective, and they leverage symmetry to derive this result. What we do is we don't have symmetry. We allow for vertical and horizontal differentiation, we characterize all the equilibrium outcomes.
Just the fourth and fifth bullet points under your paper.
Yes.
Isn't there a conflict?
The
seller always benefits.
Weekly. I'm sorry. Yes. Actually, I should have said always weekly. I'm sorry for the. It's a good point. Yes, weekly. And actually, it's a little bit optimistic, because there could be some equilibria that are bad. So, so I think it's interesting, because as you're going to see today and tomorrow, going from the case of soft information to the case of certifiable information will have a dramatic effect on the set of equilibrium outcomes. So, in particular, none of what is an equilibrium with soft information will be with certifiable. With soft information, we'll definitely have a lot of equilibria. With certifiable, we'll have unique or generically unique equilibria.
Can I ask you, sorry?
Yes.
Related to the question I was just asked, are there circumstances under which this benefit is stripped?
Absolutely.
Right.
Yes, example is going to come in just a second, then you're going to see. Absolutely. In most cases, it is. And that's not a new insight. You can even get that in a private value model, as is shown by Maskey and Tirol in Econometrica in 1990. So that's one of the main things there, that actually the linear in transfer case is a very non-generic case in the space of those problems. So here an allocation is feasible for some belief mu if it satisfies the standard interim constraints for the buyer, incentive and participation constraints. So the expected payoff of type T when he plays according to how T is supposed to play is greater or equal than the expected payoff of type T when he plays as T prime is supposed to play. And we also have incentive and participation constraints for the seller. So I don't want to say truthful because here we're not using direct mechanisms. This is a definition of feasibility of allocations, which is an outcome of a game. I hope that's clear.
Belief is only of the buyer.
Here I'm indexing the payouts with here. Of course, there are beliefs. That's a good point. Implicitly, there is the tau, the prior, but because the principal belief for the agent do not change in this game, I kind of forget about the tau. But because this mu is going to be important, especially if I want to talk about allocations that are feasible off path, where the belief is not going to be the prior, I'm indexing the payouts with the belief of the agent. So here it's implicit the tau. So if I go back to that slide where I defined those interim payouts, you see here the prior tau, and here the prior mu, the belief mu. I didn't use mu naught because of that thing that beliefs could change.
Vasiliki?
Yes.
So you do need to assume independence?
Oh yes, of course, sorry. That's important. I'm so sorry. Yes, sorry.
Is there anything known about what happens if there's correlation between the seller and the buyer's rate?
Well, yes. There is a paper by Sergei Severinov in JET, and he actually shows that you can have equilibria where you have extraction a la Kremer-MacLean type. Yes. I read this paper a long time ago. I think it's just private values. I think. But yes, but there is that paper in JET. Yes.
Why? What's the problem if there's a correlation? Following this question. I mean,
Maybe there is no problem. I haven't thought about this. There were many other things that I had to think about this. I don't know. Let me think. Let's do the proof, and maybe we'll figure out that there is no problem. But I don't know yet. I don't know at the top of my feet now. We played with some examples with correlation at the beginning, and then we got stuck with some other issues when we were trying to solve the problem. And then we never got back to the correlation, to the case with correlation. But actually, thanks for pointing that out. Maybe there is no problem, but definitely for the method of proof that we're going to use next time, there is a problem with correlation. For this one,
obviously the mu would depend on.
I don't know. Let me not say something wrong. Let me not say. Okay. So this is the solution concept we are going to use, which is properly written in Myerson 1983. So here is just a summary. The proper definition takes a page and a half. So this is just a shortening. So an allocation is an expectational equilibrium. So if you're wondering what is this, essentially strong perfect Bayesian equilibrium. If and only if it is feasible for the prior. So this word here, when Myerson writes the solution concept for this belief prior, he employs the inscrutability principle, which I'm going to explain now. So an equilibrium basically allocation, let me tell you first the definition, I will explain what this is. It's feasible for the prior and basically immune to deviations. Let me elaborate on each point. Why is it without loss of generality to look at equilibrium allocations which are feasible for the prior? Suppose you had an equilibrium where type S1 was offering mechanism M1 and type S2 was offering mechanism M2, and that was actually indeed accepted and played. Then you can have this, if this is a result to something feasible, that means that the buyer or the agents, knowing S1, they are playing this game. They are playing, if you think about this mechanism being direct, they are telling the truth and they are participating along the path. Along the path, we can actually look at direct mechanisms. It's okay. Now, if you have the principal propose a mechanism which says, okay, if you're S1, we're going to do M1, and if you're S2, we're going to do M2, this proposal does not reveal whether the principal is S1 or S2, which means that when the agent plays this mechanism, he doesn't know whether it is the principal is S1 or S2, so he's best responding in expectation. And we're going to get more feasible outcomes under those conditions. So basically, it's without loss of generality not to have proposals reveal information to the players. Why? Because we're going to make their best response constraints or the incentive constraints harder to satisfy. All right, so when we want to evaluate whether an allocation is an equilibrium, the first thing we have to ask ourselves, is it feasible? Because if it's not feasible, it means that it's not equilibrium outcome of any sort. The second thing we have to evaluate is that it is immune to deviations. So to show that something is immune to deviation, we have to show that there is no profitable mechanism deviation, which means for every mechanism I could imagine, there is some belief, nu tilde, about the principal. So for the buyer, about the seller's type, so the buyer has some belief, nu tilde, and reporting and participation strategies that form a continuation Nash equilibrium of that deviation given belief that yield an allocation or an outcome such that the interim payoff vectors of the seller are V tilde of S, which is less or equal than V of S, which is the interim profit vector of the seller corresponding to what we are conjecturing is an equilibrium, and that has to be true for every seller type. So that's what it means for something to be an equilibrium. So to show that something is feasible, we have to show that to show that something is an equilibrium, we have to show that it is feasible and immune to deviation to arbitrary mechanisms. So this is like a signaling game with enormous strategy spaces for the sender, the principal. And off-path beliefs are arbitrary and key for how deviation is played. So now essentially to find that something is an equilibrium, we have to do like a belief design exercise, find the deviation dependent worst belief that makes this deviation unattractive to all seller types, and this is delicate. So each of these three papers I mentioned to you have ingenious ways to establish this. And this is why I recommend reading. So here, okay, so now it's time for an example, now to see a bit more things concretely, a simple example. So suppose that you want to sell tutoring services. You want to teach somebody maths. So the tutor is the seller, and his previous experience is private information, that's his type. So there are two types. There is a tutor who is an expert with struggling students, and there is a tutor who is an expert with gifted students. And there is a buyer, the student, who can be one of three types. So these are equally likely. And the student is either a struggling student, TL, who values basically the tutor that knows how to deal with his case, or is a gifted student who also cares about tutors who know how to deal with her case. No, I'm joking. And there's an average student who is actually indifferent. So this is like, the average student doesn't care. Some tutoring. So now the seller is a struggling graduate student. We all have been there. We want just to maximize payment. And the buyer will accept a contract if his expected valuation from this deal that the tutor is offering exceeds the expected payment. So this is basically the utility or the match function or the valuation function of the buyer. So the struggling student values at 30 the services from the tutor that matches his needs, and 0 to the tutor that is good with gifted. The gifted student, he doesn't care about those who are good with struggling. He wants to pay 32 for the tutors that are good for his thing. And the average student, he wants to pay 20 regardless. Everything is equally likely. So in this example, the first thing what can you do here to sell? What can you offer to this student? So the student doesn't know. You don't know the student's ability. He doesn't know your expertise. But you have the ability to ask him the terms of the agreement. One simple thing you can do is actually say, look, you have to pay me $15 an hour for this. What's going to happen is, so if you just ask for $15 an hour, all types of student will accept, because every student type values your service in expectation at least at 15. This guy will get 30 with probability a half and 0 otherwise, so that's 15. This guy will get, with probability a half 32, 16, and this guy gets 20. So 15 is actually a nice thing.
So here, seller only suggests 5, the only message.
Yes, here I'm just discussing procedures. So here I'm going to actually show you an environment where there are different mechanisms, and I'm going to actually discuss which of these mechanisms are equilibria. One mechanism is to ask a price of 15. Yes, just the price, nothing.
So mechanism here is a selection of mechanism, selection of price.
Yes. A price is a mechanism.
Okay.
If you accept it, you get it with 1. If you don't accept it, you don't get it.
Okay, so what's the difference between this and just standard costed price?
Nothing.
Sales or,
Nothing.
here,
But there are no possible deviations.
Yes, so
That's what she's saying.
I'm going to show you that this is an option you can do, and I'm actually going to evaluate, is this an equilibrium? Now I'm going to show you 4 or 5 different things you can do. Another thing you can do is actually go to somebody, find a way to communicate your information fully to the student, so create a situation of full information, and then do the Meyerson's approach. So suppose here the student knew whether you are SL or SG. The papers in optimal auctions, so Meyerson and Maskey and Riley, will tell us the best procedure for the seller is to ask a price. What price would you choose if the student knows who you are? Well, if the student knows you are SL, you have no hope extracting any money from TG. So what the best you can do? You can either ask a price of 30 and sell with probability 1/3, or ask a price of 20 and sell with probability 2/3. So you will ask a price of 20. The same thing for SG. So here you see immediately, and that will yield 20 times 2/3, which is 13.3, is less than 15. So here immediately you see that the fact that the seller has private information is beneficial for him, because he can just ask for 15, which is better than the best thing he could do if the consumer knew who he was. So that doesn't take a lot of, that's like a very simple way to see that in this example at least, the seller likes the fact that he has private information. At least in this, now we haven't talked about whether these mechanisms are equilibrium. We know that they're feasible, because if you ask a price of 15, the consumer will accept it. If you ask a price of 20, it's easy to see that those consumers will accept the price and they will implement this allocation. Another thing that you can do, which is nice, and I will explain why it is nice. We don't have so many slides, so this is for both lectures if you're getting anxious. And there are a lot of pictures in the second lecture. So all the words came today. Tomorrow it's going to be. But okay, so in this scenario, I'm sad that the Sergio is not here, because this is his thing, like talking. not here in the long cheap talk paper. I meant to say, they have a paper that's called long cheap talk, right? Yes, talking not in the lecture room, talking in the game theoretic sense. So here the seller is going to tell the buyer RUTI. So if the buyer says yes, then the seller is going to say, okay, 20 per hour. If the buyer says no, then the seller will tell him, oh, I am a seller G, and the price is 30. So I claim that actually, given this communication, if people tell the truth, so basically the buyer replies yes, or this is a yes or no question, first of all. So if the buyer says yes, then he will be quoted a price of 20.
So what is TI? So the seller is SI.
TI is the indifference type who doesn't care. There is a different consumer. So this is like hoteling. Think about hoteling. There is a guy in the middle, there's a guy to the left and to the right. So this is the middle consumer. He doesn't care. Whereas the left and the right guys, they care about where they are. So the TI person is going to face a price of 20, he will accept it. Now, if the buyer tells the seller, no, I'm either one of these guys, then the seller, he can just tell the truth about what he is and ask a price of 30. This price will be accepted only by the right type, and it's not going to be accepted. So TL is going to want to pay 30 for SL, but 0, and TG is going to want to pay 30 for SG and 0. If you look at this, it is incentive compatible and feasible for that matter. Why it is incentive compatible for the buyer? Well, if TG behaves as his TI, he will have to pay 20 for something he doesn't like. And if he pretends to be the other guy, he will get the good when he doesn't want it. So it's easy to see that it's incentive compatible. Now, why is incentive compatible for the seller? Well, if you look at the expected profit of those types, the interim ones, they are the same, because here SL gets 30 with probability 1/3 plus 20 with probability 1/3, and this is exactly the same for SG. So the payoff vector is 50/3, and it's the same for both. This is nice because this procedure is not identical, but kind of resembles what this procedure that is a lot used in practice, but it has not been easily rationalized by standard auction theory, the process of book building. So when companies are selling assets, they are doing this communication. They are doing non-binding offers, non-binding indication of interest. All of this is cheap talk. And in the standard framework of auction theory, it's very hard to rationalize cheap talk. Why wouldn't you just do a reserve price? And there are some papers by Hendricks and Quint and maybe other authors. I'm blanking on the name, but there's Paul Migler talks about it also in his book. There are some papers that try to rationalize this procedure as in cases where bidding is costly, and this cheap talk allows selection of bidders in situations where bidding is very costly. But if you look at the data, half of company sales in the US which who use this procedure of book building are between one buyer and one seller. So bidder selection is not an issue there. I think what could be going there is that in those situations there is something to be learned about the quality of the match. How useful the assets that you are selling me are for my assets, or how useful the lesson you're offering to me is useful for me. So when the seller asks the buyer UTI, he's asking him, do you bother about my type? Do you care who I am? The TI type does not care, so he's going to face a low price, whereas the other types care. So here the seller is selling information and the good. To the types that they care about information, the price is going to be higher. So give me 1 second. You can implement this procedure with a consulting fee plus an acquisition fee, something equivalent to this. So yes, questions. He was first, sorry. Oh, yes.
Very short one. Why not 32?
Why?
In the original table, it was
52.
42, right? Here
Yes,
we
yes.
have 30.
The next slide. Next slide.
So it's not you can't deviate here to 32, right? Seller.
It's the next slide.
Okay.
Just understand. The information of the seller gives is verifiable.
No.
So why does the buyer agree to pay if it's not verified?
Because the seller doesn't have an incentive to lie. Ex ante, he doesn't, because why?
Then I lost the money. If they,
Absolutely, but if no matter what I tell you, you will accept my price with probability a half. I don't know who you are. So if I tell you I'm a cell and you are SG, I'm in trouble. If I tell you I'm SG and you are a cell, I'm in trouble. Both have nothing to gain by mimicking each other. So yes.
Well, doesn't SL have something to gain by mimicking SG? Because if they do match, then he gets 32 instead of 30?
Not according to his protocol. I put the
Okay.
price 32.
So why doesn't he do a different protocol? I guess the same as he's supposed to.
Yes, because this outcome is better. Everybody saw that. I'm happy that you are on board. But this thing is not equilibrium feasible because the revenue of SG is higher than the revenue of SL. So then these would want to mimic that, and that would break down. This outcome is not feasible because the seller wants to lie. As I told you, a necessary condition for equilibrium is that an allocation. So here I'm depicting allocations with these matrices, probabilities and transfers. Sorry, I haven't been very clear, but I guess we inferred it. Everybody's very smart. So here this allocation is not feasible because it doesn't satisfy the seller's incentive constraint. SL would want to say I'm SG because he would get 52/3, and that's not. But we can actually attain this with a feasible mechanism. And that is always true in this model where you have transfers. That's why on one hand it's very general, on the other hand it's special, but at least I think we're learning something useful. So how can you make this guy feasible? In this case where we have risk neutrality, it's simple because you can replace the payment with its expectation. So in particular, if I replace 30 with 15 here and 15 here, and this is 32 with 16 and 16, I respect all the interim participation and incentive constraints of the buyer, and I make both lines for the seller the same, the payments, which is what he cares. So every seller type gets 51/3, and everybody's happy.
so here the buyer is fixed right, and then the seller is the price.
Here, this is a direct mechanism mediated. So this mechanism, this outcome I can implement only with a mediated procedure, not with a natural communication procedure like this one. This one is beautiful because we can just talk and quote prices. This one, and actually non-commitment prices, we can condition the prices on the conversation. Here, there is a lot of commitment. I'm going to offer this computer to the buyer that says, if we report TL and SL, you're going to get the good and pay 15, which is you're happy. But if I report SG, you're in trouble because you're not getting the good and you're still paying 15. So now you see that the fact that we're imposing interim participation and incentive constraints, as in most mechanism design literature, has a bite. Because if I want to offer money back guarantee here, obviously I cannot do that. But we are in the space of interim participation and incentive constraints in this paper. So in that, if you're willing to accept those interim constraints, this satisfies these constraints, and it's a mediated procedure, and it's actually the ex ante optimal mechanism. Why is ex ante optimal? It's trivial to see because it extracts all the surplus from the buyer, all of it. So here there's no correlation, it's just a particular payoff structure, and no Kremer-MacLean lotteries. But again, you have that you satisfy interim the constraints in expectation. Yes.
I'm probably missing something simple. Can't the seller say, but what do you mean? SL wants to mimic SG. The seller comes to the buyer and says, okay, tell me if you're TI, and then tells you like the previous step, right? And then he said, if I'm commits that if I'm SG and you in the agent reports SG, I have to do it as well. I'm not sure I want my nonsense to be heard. Anyhow, if I'm SG
Yes.
and you report that you're PG, then there'll be a transaction at the price of 32. If
Yes.
What's the problem?
Because then
What's the problem?
the problem.
He commits to the price as a function of his time, no?
Well, not
The
his.
function of his review.
He was revealed type of his report. So then SL can say he's SG.
You get
It's a
32.
function of his review.
Yes.
Okay.
That's the thing. Tomorrow there's not going to be. Tomorrow you cannot do this.
Yes.
Tomorrow.
Sorry.
No, it's okay. Tomorrow you will not be able to do this because under some evidence. But here you can.
I
Yes.
forgot that we have more evidence.
It's okay. Okay. So, all right. So the remarks on this procedure. So, just now, this is not very much related to informed principle, but it's interesting to see that posted prices are often a revenue maximizing procedure with one buyer. So there are many environments that have that feature, Ireland, Zeckhauser, Myers, and Ilankaya. Here it's not even ex-ante profit maximizing, and you see that bilateral chip talk helps. So it's interesting because in standard auction environments, although we use the mechanism design technology, which encompasses many games, usually you can implement the optimum with very simple tools, with reserve prices, no communication. Here, you see that communication can become important, either through a mediator or through cheap talk. So I guess the best you can achieve with mediated procedure, where you really need the mediator.
So, that's a question you asked me? Oh, I'm sorry. No, go. So, have we proven that these are equilibria?
Not yet.
We've just shown that these are all feasible mechanisms.
These are feasible.
Okay.
So now I'm
The
going to...
last one, is the mediated one, do we know if that's an equilibrium?
Not yet. Not yet.
Excuse me, can you say just again how the mediation works?
There's a machine.
There's a machine.
No. I mean the details. I simply miss the details. Can you say it?
The
Can
chip
you
talk.
just go back
The
and
chip
say-
talk.
Yeah, the way to extract.
Oh, this thing.
Yes.
Oh, this thing, you don't do any, you just offer a computer
Yeah.
mediator, and they report truthfully because they cannot lie. Here, if you lie, you get the good in the wrong. It's incentive compatible to report your truth, and once you have the inputs, which you will report truthfully here, you will get this outcome. So this is incentive compatible. Why do you see it's incentive compatible? For the seller, the payments are identical in both lines. That's what he cares about. For the consumer, if he's TG and he says TL, he's going to get the good when he doesn't like it, and vice versa. And then if they mimic TI, they're going to be getting the good when they don't want it and pay more money. And TI doesn't want to mimic those guys because he wants to get the good all the time and pay 20, whereas here his surplus would be less. So that's how it works. So now, which of these procedures are equilibrium outcome of the game where the seller will propose the mechanism, knowing his type, and can choose any mechanism on and off path? That's what we're after. And the answer is all of them. And many more. And any allocation yielding revenue on the 45-degree line between 40/3, which was the full information revenue, to 51/3 is an equilibrium. So ex-ante optimal revenue is an equilibrium, full information mechanism is an equilibrium, pooling posted price is an equilibrium, and bilateral chip talk contingent prices is an equilibrium. Has a flavor of that we get a lot of equilibria, as in your paper with Jean Tirole in the 1992. The difference is here that the Rothschild-Silix allocation we have is not weakly interim efficient for interior beliefs, and we're going to use a different, simpler way to show actually that these are equilibria. So I think this is basically what we do in this paper. And what is important for the proof of this theorem is that the seller only cares about revenue. So if you think that there are environments where this assumption makes sense, this is what's happening. In tomorrow's lecture, we are not going to impose that restriction. So the environment we're going to look at is going to be more general because we're going to allow for arbitrary reservation values. But here we are using this assumption. So what this assumption implies, it implies something that makes life very easy or easier. It implies that basically at any feasible allocation, every seller types make the same amount of money. Why? Because if all I care about is money, if one type makes more money than another, that the type who makes the most money is going to be mimicked by everybody else. So in order for a payoff vector of the principal to be feasible, it has to yield the same profit to every type of the principal. And that is very helpful because it allows us to pick one belief that works for all deviations. And even though we have this environment where the agent's type is not necessarily increasing or decreasing in the seller's type, it could be anything, we can actually have a so basically how the buyer evaluates different S's is not clear, because for T1, for TL, the worst type was SG, and for TG, the worst type was TL. So there is not one worst type, but in general, there is one belief that works for all deviations, and is the belief to put probability 1 to the type that has the lowest full information outcome. Now we'll show you how this works. So this is what we used to characterize the following theorem. So this is actually an if and only if result. So the profile of interim revenue is a profile of expectational equilibrium interim revenue if and only if it's x of s is equal to x of s prime, which, as I said, must be at every feasible thing, and this x of s is less than the x of ex ante optimal. You cannot get more money type by type than what the seller could get if we was maximizing revenue ex ante, obviously. So when we're maximizing revenue ex ante, we're going to get a number that does not depend on S, because it's an expectation over all seller types. So this is just a number. So let's they say that this number is 10. Now, what this says is you could have an equilibrium profit vector where every S makes 10. And obviously on expectation it will be 10, but it cannot be more than, for every S it has to be less or equal than 10. And that is great, good, because it shows you that something nice is an equilibrium. And here, this is a little bit of a pessimistic point of view, because this tells you that you can have an equilibrium profit vector where every seller type makes the amount of profit that is lowest among the full information profit vectors of all his type. So suppose that there were like 3 types of seller, and when each 3 of these types would do the Meyerson auction, seller 1 would get, let's say, type 1 would get 10, type 2 would get 2, and type 3 would get 1. This type 3 will set the common ground for everybody, because it will say that we can have an equilibrium of the informed seller problem where everybody could be getting a payoff of 1. So, and everything in between is an equilibrium. So this is the theorem. Excuse me? It's not efficient. It's ex ante profit maximizing for the seller, which it could be inefficient. In the example I showed you, it turned out to be efficient because the good was always assigned to the buyer. So here, whenever there was positive surplus, the good was always assigned. So that assignment is efficient. And it turns out to be ex ante optimal, but in general that's not true. Let me see what I want to say. So I'm going to kind of do a little bit of a hand waving of the proof, because it's not a very difficult proof, and that's in contrast with all the other proofs in this literature. It's a simple proof. And so it kind of gives you courage to read the other papers. because the other papers, at least for me, they took some courage. I don't know for other people, but they are very deep. They are deep papers. So this is very simple compared to those papers. So here, as we said, in any feasible allocation, every seller type must make the same amount of money, and that's regardless of the belief. So for any belief, that's true, not just for the prior. So to show, let's take an allocation that has a vector of revenue that satisfies 1. Then we want to show that this is an equilibrium. So how we can show that this is feasible? We take an ex-ante optimal mechanism. So I didn't define it here formally. An ex-ante optimal mechanism is one that maximizes the ex-ante profit of the seller subject to Bayesian incentive compatibility and participation constraint for both seller and buyer. So it is feasible by definition. And now I'm going to use this mechanism to construct a mechanism that has the same assignment, but a transfer rule that yields exactly X of S to each seller type. How do I do that? Is I set X of ST equal to the ex-ante optimal, an ex-ante optimal ST. I subtract this constant number minus X of S, which is what I achieve. And when I take expectation of this with respect to T, this cancels out with this. And why is that? Because at the ex-ante optimal, every seller type also makes the same amount of revenue. And then I get that this is feasible. And because I know that this is feasible, I have the assignment and I have the payment. It's feasible and it generates X of S. So so this is feasible. So now we have to show that it's immune to deviations. All right. So suppose, so now I have this direct mechanism that implements the payoff vector I want, and I have shown that it is feasible. And I want to show that deviating to any alternative mechanism cannot be profitable. So suppose there is a deviation mu tilde, then we can assign a degenerate belief that puts probability 1 to S lower bar, which is the S with the minimal full information revenue. And let P tilde X tilde be the continuation Nash equilibrium of that deviation given this belief. Then the worst type of the seller cannot be made, because the belief now just put probability 1 to S lower bar, S under bar. By definition, S under bar does not make more money than this, because that's his Meyerson whatever payoff. So this deviation must give him less or equal interim payoff. And because every seller type makes the same amount of money, X tilde must be the same for all S, all seller types make this little amount, and that's that it satisfies this inequality. No, this X of S can never be below X of S. That and this. So basically, this way we can show that we can kill every deviation in this way. And then you can actually show the reverse, which is simpler. If that's an equilibrium profit vector, then it satisfies the property that it's between the ex-ante optimal and the full information. So I'm not going to show you that. So here, what is the trick? How this construction uses a special feature of the model? It uses the special features of the model in that we use a lot the fact that all seller types must have the same amount of profit, and we can do easy modifications of mechanisms because we can just use the assignment and then modify easily the payoff vectors of each principal types, which you cannot do in general if the principal has more general payoff structures. And we're not going to be able to do these tricks tomorrow in particular. All right, so here, an important question in the informed principal literature, which has been kind of focal, especially in the recent papers by Milovanov and Traeger, is whether basically the principal is better off, is there an equilibrium where the principal is better off being informed versus being uninformed? That's not an obvious question. Why? Because when you have an informed principal, you have to deal with two additional constraints. One is a constraint that you have to respect incentive compatibility for the principal, and the additional constraint is that the thing you're getting has to be immune to deviations. So it's not. So these are two additional constraints. On the other hand, the principal has information. We talked about information design. So if we put now this exercise in the, if we try to parallel this exercise with the information design exercise Emir was talking about, in those problems, you have somebody designing an information structure at the ex ante stage. Here, you have a party at the interim stage designing not just the information structure, but actually the physical terms of the agreement. In the information design literature, I can just control what you know. Here, I can also control what we're going to do. So actually, in one sense, we have more tools. In other sense, we have less ability to achieve things because we have non-commitment. So the choices are done in the interim stage. So it's not clear how this answer is going to play out. But as I'm going to explain here, and we highlight in the paper, is that in this problem, there is always an equilibrium, as we said, which is better than the full information allocation. Okay, so there are some situations where actually the seller does not benefit from having private information, but that does not mean that the full information thing is an equilibrium, which is different from the paper in private values. So with private values, Musk and Tirol's paper in 1990, full information is going to coincide with SUPO, and it's an equilibrium. Here, the full information, we're going to be getting the same payoff in some sense, but not this, from the ex ante perspective, but not at the interim. So let me explain what I mean. Look at this example. Two types of seller, two types of buyer. S1 gives 6 to T1, 7 to T2. S2 gives 0 and 1. So S1 is a good type here. Both T1 and T2 like it more than S2. What is the full information thing? S1, he can ask everything equally likely. S1 can, if the consumer knows that it's S1, S1 can ask a price of 6 or of 7. The optimal thing is to do is to ask a price of 6, right? If we, S2 now is cannot do really much. He can only ask a price of 1, and his revenue is a half. So the full information will give 6 to S1 and 0.5 to S2. Ex ante, we will have a half 6, a half 0.5, so 6.5 over 2. That's the ex ante thing, the ex ante revenue corresponding to 6 and 0.5. Actually, this is also the ex ante optimal thing you can do. You cannot do better. And these are two ex ante, you have to believe me in this. These are two ways to implement an ex ante optimal, two alternative ways. One is this way where you give the good to everybody, and actually here T2 pays a half. Another way to implement it is this way, where T1 pays 3, regardless of whether he gets a good or not. T2 pays 3.5. These two things, if you look at those two implementations of which are ex ante optimal, they are also incentive compatible, because both S1 and S2 make the same interim profit, 6.5 over 2. So these are this is the unique equilibrium prediction here, because it coincides, full information profit vector and ex ante optimal, but the full information allocation is not an equilibrium because it's not incentive compatible. It gives a half to S2 and 6 to S1. So now you see the difference, that the ex-ante payoff of full information could be the same, but the implementation could be very different. But from the ex-ante perspective, in this example here, the seller is weakly indifferent between having information and not having information, from the ex-ante perspective. Does this make sense, what I'm saying? Because I just ran out of time. So what I want to say, the fact that this example is increasing and the seller is indifferent between being privately informed or not from the ex-ante perspective is coincidental. We have an example in the paper with strictly increasing U, where the seller is strictly better off having private information. So it's not, the U is monotonic, so we have conditions that actually, we characterize conditions that, sufficient conditions under which the seller is indifferent, and those conditions are related to this literature on whether we can implement base and incentive compatible mechanisms with dominant strategy incentive compatible mechanisms. There is an analog, and maybe I'll have more time to talk about this next time. So that's all for today, and